Hello, hello. Here is the video going over the Unit 8 Statistics review in preparation for your upcoming quiz. So the first thing we're going to look at are dot plots. So a dot plot will tell you how many people fit into each one of those categories. So for example, the dot plot shows the number of students in each of the teacher's classes. How many total students are there in all of the classes? There are 30 dots. If you go through and count everything, there's 30 students. Go ahead and put my units there. 30 students. Since each dot represents a student, which class has the least number of students? That would be Daisy. And which class has the most number of students? That would be Even. All right, those questions are pretty easy. Moving on to our next dot plot. The dot plot shows the number of lemons each person has. So how many total individuals are represented in the dot plot? There are 28 people if you go through and count each individual dot. What is the total number of lemons that the individuals have? So if I look at the number 11, there are 4 people that have 11 lemons. So what I can do is I can total up the number of lemons in that category. So I would do 11 times 4 for those 4 people. Plus, for the 12 lemons, there were 3 people that had 12 lemons. Plus, for the 13 lemons, there were 6 people. Plus, there was only 1 person that had 14 lemons. Plus, for the 15 lemon category, there were 5 people. No, I can't. Let me count again. 1, 2, 3, 4, 5, 6 people. For the 16 lemons, there were 5 people that had 16 lemons. And there were 3 people that had 17 lemons. So after you go through all of that multiplication and add everything together, there ends up being 393 lemons all together. For number 3, the following data shows the amount of chocolate Mrs. Latimer ate over the last 30 days. Create a dot plot to show how much chocolate she ate. I went ahead and already put the numbers on my dot plot. I'm also going to title it. I can go ahead and title it number of chocolates eaten. Cross through my own stuff. Number of chocolates eaten. And all I'm going to do is I'm just going to put a dot on top of each number as I go through the 30 days. So the first day she had 3 chocolates. Second day she had 5 chocolates. Third day she had 9 chocolates. I'm going to go ahead and cross off as I go. Then she had 2 chocolates, 4 chocolates, another set of 5. Again, crossing off as I go. 3, 8, 7, 4. So just going through all these numbers and putting these dots in the right spots. Okay, and then she had 1, 2, and 2, 5. I wonder what kind of chocolates these are. Because when you're having 7 chocolates, that's a lot of chocolate. And now she's having 12. I wonder what kind of day she had when she had 12 chocolates. And then 6, 3, 7, 9, 2, 1, 7, 4, 3, 9, 4, 3, 9, and 11. So there right there is the dot plot that represents the number of chocolates that Mrs. Latimer ate over those 30 days. All right, moving on to box plots. So this box plot shows the ages of clerks in a supermarket. Use the box plot to answer the following questions. So first and foremost, I'm actually going to label everything in my box plot. So that 22 is going to be the min. 25 is your first quartile. 34 is your median, 36 is your third quartile, and 39 is your max. So that helps me answer the questions that follow. So the median age is 34. The maximum age is 39. Find the range of the clerk's age. So range is going to be max minus min. So I'm going to take 39 minus 22, and that gives me 17. Interquartile range is a little different. Interquartile range is going to be your third quartile minus your first quartile. And what that tells us is that tells us the range of the middle 50% of the clerks. So I'm going to take 36 minus 25, and that interquartile range is going to be 11. What percent of the data is over 36? So if we look at our box plot is separated into sections. Each section is 25%. So from here to here, that's 25% of your data, another 25%, another 25%, and another 25%. It does not matter how big each section is. You could have really long stretches towards your max and mins. You could have different portions of your box being bigger than others. But again, each portion is going to represent 25%. So what percent of the data is over 36? I can see in my box plot from 36 to 39, that's one portion of my box plot. So that's going to be 25%. If 60 clerks were surveyed, how many are under 25 years old? Well, first I want to figure out what percent is under 25. That is going to be one portion of my box plot. So that's 25% of the 60 clerks. So I can take 0.25 times 60, or I can take 1/4, since 25% is a quarter, 1/4 of 60, and that's going to give me 15 clerks. And finally, what percent is between 25 and 36? So that is going from here to here, and that's two portions of my box plot. So that's two portions of 25%, so 50%. All right, next question. So 11 students were randomly selected and asked how many Snapchats they received in an hour. Make a box and whisker plot of the data. So the first thing you need to do is actually put your data set in order, which I already did, so I didn't have to waste your time having you watch me put it in order. From there, I can go ahead and find my max and min pretty easily. My min is the lowest number, max is the highest. And then I'm going to go ahead and find the median. The median is going to be right in the middle. So I have 11 pieces of data. I'm going to go right in the middle, and my median is 31. From here, your median separates your data into two halves. The median of the lower half is going to be quartile 1. So once again, I'm going to find the middle of my bottom half, and that's going to be quartile 1, and I can find the middle of my top half, and that's going to be quartile 3. Now that I know what numbers I'm actually dealing with, I can go ahead and create my number line. I can see my min is from 24 and my max is 36. So I'm going to go ahead and start my number line at 20, and then just continuing until I get the correct range of numbers that I need for this particular data set. So here we go, writing all my numbers. 28, 29, 30. I did not write small enough for this. 31, 32, 33, 34. I'm going to stretch this out. 35 and 36. Okay. Didn't write small enough, unfortunately. So my min is 24, so I'm going to go ahead and put a dot above 24. My first quartile is 27. median is 31, quartile 3 is 34, and my max is 36. So in order to create my box, I'm going to go around my quartile 1 to my quartile 3, and that's going to create my box. Line goes right through the median, and then I can extend in both directions to my max and my min, and those are going to create your whiskers. And of course, we do need to title it. That way our box plot does have an actual name, and so we'll call this number of Snapchats. Oop, can't spell. Snapchats. All right. Histogram. So we want to create a histogram for this particular set of data. So it's the number of chocolate candies per bag of trail mix. So the first thing I'm going to do is I'm going to tally how many numbers actually fit within each one of these intervals. So I'm just going to go in order. I have 50. 50 is going to be in this interval over here. 42 is between 41 and 60. 100 would be down here. 45, 68, 32, another 100. So I just did the first row. Second row, I have 67, 61, 31, 75, 39, 62, 64, that's my second line, 49, 55, 51, 33, 99. 99 would be down here. 96, and finally 64. So now I'm going to total up my tallies. So from 1 to 20, I didn't have any. For 21 through 40, I had 4. For 41 through 60, I had 6. 61 through 80, I had 7. And 81 to 100, I had 4. And now I'm going to use those values to create my histogram for chocolate candies per bag of trail mix. First thing I need to do is I need to actually label my x-axis, my horizontal axis with my intervals. This one goes from 0 to 20. My next interval is 21 through 40, 41 through 60, and 61 through 80, and 81 through 100. And what I'm going to do is for each one of those intervals, I'm going to create a bar for the frequency of that particular interval. So from 0 to 20, I didn't have anything. From 20 to 40, I had 4. So this bar is going to go all the way up to 4. For 40 through 60, I had 6. So this one's going to go up to 6. 60 to 80 or 61 to 80, I had 7. And finally, 80 to 100, 81 to 100, I had 4. And there is your histogram. You can go ahead and color the bars if we want to, fill them in. You don't want to waste too much time coloring these in, because that would be pretty boring to watch. But there is your histogram. All right, outliers and distributions of shape and spread. Label each histogram according to its shape, symmetric, normal, skewed left, skewed right, or uniform. So if I look at my first histogram, I can see that it's pretty even on both sides. So that is going to be symmetric or normal. For my second histogram, I can see the bulk of my data set is hanging out over here, and then it tapers off to the right. So wherever it tapers off towards, that is where the skew is heading. So this is going to be skewed right. Similarly, for the next one, I can see the bulk of my data is over here with my tail heading to the left. So this would be skewed left. And if I look at my histogram, most of my bars are at relatively similar heights. So this would be uniform. Okay. Now we're going to answer some questions about the histogram. So use the histogram to the left to answer the following questions. What does it mean to be an outlier in the data set? An outlier is something that lies outside most of your data. That's why it's called an outlier. It lies outside most of your data. So basically, it doesn't belong in your data set. So it's something that's pretty different from the rest of your data. So it lies outside most of your data set. What might the outlier affect the mean, or how might the outlier affect the mean of the data set? Your outlier will always pull the mean in the direction of where the outlier is. So for example, if your outlier is smaller than the rest of your data set, then that's going to make your mean smaller. And vice versa, if your outlier is larger than your data set, then that's going to make the mean larger. So it's going to pull the mean in that particular direction. How might the outlier affect the median of the data set? So if we were to actually take out the outlier, depending on how many pieces of data you have in your data set, it could slightly change the median just because it might shift where the middle is. So it could, I'm just going to write slightly change. Since it could shift, since taking out the outlier could shift the median. All right. Next up, two-way frequency tables. So let's say, we surveyed 11th and 12th graders on whether they rode the bus or drove to school. Use the two-way frequency table to answer the following questions. Calculate the totals for each row and column. These are your marginal frequencies. So I'm just going to total up all the columns. I have 11 plus 7, that's 18. So that's my total of the students that ride the bus to school. The total of students that drive to school is 32. The total of students that were surveyed in 11th grade is 23. Total of students that were surveyed in 12th grade is 27. And my total is going to be 50. So how many students drive to school? So the total number of students that drive to school is 32. Just looking at your frequency table. Of the students that drive to school, what percent are in 12th grade? So I'm going to look at just the students that drive to school. So I'm looking at this column right here. And of those students, how many drive to school? Well, that's 12 out of, oh, wait a second. Oh, what percent are in 12th grade? Sorry, I misread the question. Of the students that drive to school, what percent are in 12th grade? So the ones that are in 12th grade is 20 out of the 32. So that's what you would write for your proportion. For your proportion, you write the fraction. And then we can change that to a percent. So if I were to put that into my calculator, that would give me 0.625. And I can move the decimal place over twice. So that gives me 62.5%. Of the students who drive to school, so I'm still looking at the same column, what percent are in 11th grade? That would be 12 out of the 32. And once again, I can put that into my calculator to give me the decimals. That's 0.375, which I can then change to a percent. So that's 37.5%. I am going to go ahead and erase my yellow circle because we might be looking at different rows and columns for the next sets of questions. So number 5, how many 11th grade students were surveyed? So I'm going to take my total for 11th grade. That's this right here, 23. Of the students in 11th grade. So now I'm just looking at the students in 11th grade. Of those students, what percent ride the bus to school? So that is 11 out of the 23. So that's my proportion. And again, I can put that into the calculator to divide it. That's going to give me 0.478, which is 47.8%. Of the students in 11th grade, so I'm still looking at that row, what percent of students drive to school? So that's 12 out of 23, which again, I'm shove that into my calculator, gives me 0.522, which is 52.2%. All right, so that is all of the questions in your review for your statistics quiz. Good luck on your quiz.